Okay, so today I'll be going over a brief summary of basic matrix operations. So I'm probably going to make this a series of 2 to 3 vids because this is kind of large. It's a basis for a lot of the stuff that happens, pretty much everything that happens in linear algebra. So you have to understand it, and I have to go through it thoroughly. Um, and I'm going to start from the very, very beginning. Okay. So first, everything that we do in linear algebra has to do with systems of linear equations. Anything that can be written as some number times x plus some number times y is equal to some number c, where a, b, and c are all numbers. They're non-zero constants. That's what we call them. And then x and y are variables, also known as unknowns. Um, and I right at the bottom that symbol is the square root because I was having trouble plugging it in here. Um, but a system like this, we're going to eventually denote in matrices. So we're going to write the numbers are the coefficients in this system of linear systems usually. So our first example, to show how this works. So you want to determine which of the following equations are linear by inspection. Inspection means just looking at it and knowing. So the first equation, x plus 7y equals 8. We see that the constant in front of x is 1, and x isn't raised to any power, it's simply just x. That's the same with y, except it's being multiplied by 7. But since 7 is a non-zero constant, and it's equal to c, which is 8, this is a linear equation, a linear system. And then our next equation, xy squared equals 8, is not, because x and y are being multiplied to equal a constant, and it can't be written in the form ax plus by equals c. So therefore, it's not a linear equation. Then our third equation, the square root of y plus 8x equals 10 is also not, because we can't make an equation ax plus by equals c out of that. So you see how that works? Basically, it's pretty easy to tell. If you see a square or square root, it's probably not going to be a linear unless there's some trick where it simplifies down. Now the last equation is linear because the square root of 5 is still a non-zero constant and it's being multiplied by x, so we can write it as ax plus by equals c. It's in that form. Here are the answers. Pretty much just what I said, just using more high-level vocabulary. This is how if you were in a class taking this in a class, you probably answer it using these terms. Okay, so here's a key idea with this. So every system of linear equations has no solutions, exactly one solution, or infinitely many solutions. So basically it means a linear system is just a group of lines. Each equation represents a line. They can either cross, not cross, or be the exact same line, which leads to no, one, or infinitely many solutions. So this picture over here shows the intersecting lines and the parallel lines, one solution and no solutions. Now, infinite solutions would look like just one line because it's literally both equations represent the same line. So it would be hard to show that. Okay. Now, if we want to set up a system and we want to find where they cross and how many solutions they have, we can solve them with elementary row operations. So I'll expand on this maybe in this video or in the next video, but essentially we take the coefficients of each term. If it's written in order x1, x2, x3 in each system, we take the coefficients, we put them in a matrix, and then we put the solutions to each system in each of the rows, and then we're going to simplify each row until we solve for the variable where it looks like 1, 1, 1 in each row. So each value in this matrix corresponds to the coefficient. So it's called the coefficient matrix. And this matrix with all the coefficients and the zeros is called the augmented matrix. And it's pretty much the base of solving matrix equations. It's what we use every single time. So in order to solve this system, pretty much what I said is we have the coefficient matrix A, which it shows down here. We have X, which is the variable matrix. It has the variables, which when we do the matrix multiplication, it's going to be AX1 plus BX2 plus CX1 plus DX2. And then on the other side is equal to B1, B2. Matrix multiplication, we'll go more into that in a later video, but all you need to know is it'll basically just flip and look like the original equation when you do this. So that's how you would write it. And then in order, if you want to represent the augmented matrix, you would represent it as A line B. And that's known as the augmented matrix. So here's another set of problems. So you want to identify the matrices. So what I mean by this is say which matrix is A, which matrix is X, and which matrix is B in this equation. So the first one is pretty simple. If you want to do by yourself, by the way, pause the video for a second. Okay, now I'm going to say the answers. So the first one is pretty simple. It's written in the general form AX equals B. So the 2, 1, 1, 0, 1, 3, 1, negative 1, 2 is going to be the A matrix. And then the XYZ matrix is going to be the variable matrix. And on the other side, the 8, 4, 4 is the solution, the B matrix. Now, for our second problem, this is a little more complicated, but essentially what we need to look at is, since these are all variables, we need to look at which matrix is being multiplied by each other to get this other matrix. So it's basically just written backwards, but anytime you see some matrix multiplied by another matrix and it has to satisfy this, you can say that this is A, this is X, and this is B. Even though, like, in terms, this will be the variable matrix in a system where we have values for these. This is called you don't know it now, but this is a lower triangular and this is an upper triangular matrix. So yeah, here are the answers, pretty much what I said, just again in using more qualified terminology. Okay, so the next video is gonna be on this Gaussian and Gauss-Jordan elimination if you want to watch it. But this is basically just a sneak peek, kind of expanding on it. So basically, to solve systems, we're going to be adding rows, and we're going to try to get them in a certain form that is going to tell us the answers. And this is going to be the basis for being able to do things with matrices that we couldn't previously do without matrices. And it's extremely important for linear algebra. This is the stepping stone for doing higher level things. Okay, so I'll make this video pretty soon, and I'll explain more, but that's all you need to know for now. Okay, thank you for watching. As always, just subscribe if you want to see more of my content, and have a good day. Thank you.